Good morning, this is your Stat Sensei, Mr. Spensei, and this is Unit 3B review, and this one is primarily focusing on the binomial and geometric and a little bit of central limit theorem. So, a company that manufactures smartphones developed a new battery that has a longer lifespan than that of a traditional battery. From the date of purchase of a smartphone, the distribution of lifespan is approximately normal. That's going to be really important because then we don't have to worry about our sample size being 30 or more with a mean of 30 months and a standard deviation of 8. So once again, I'm going to draw that picture off to the side just so I don't forget about it. So we have a mean of 30 and we have a standard deviation of 8. The warranty guarantees the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months. So if we end down here at 24 or less, we replace the battery. All right. So suppose one customer who purchased the warranty is selected at random. What is the probability the customer selected will require replacement within 24 months from the purchase because the battery no longer works? All right. So let X equal the number of months. So we want the probability that X is less than 24. Now, technically we did this in the other video, but because all the problems are based on the value we get here, I'm going to do it again. So in this case, probability X is less than 24, and we know because it's normal, we're going to have to use the Z formula. So we want the probability that Z is less than 24 minus our mean of 30 over our standard deviation of 8. We're going to go do a stat test Z test. Stat test Z test. Mean of 30, standard deviation X is 24, less than, and we get 0.2266. Make sure we write down our Z score. Equals the probability that Z is less than negative 0.75, and that gives us an answer of 0.2266. So about 22%, or a little over 22%. All right. So using your answer in part B, what is the probability the first customer to have a replacement battery is the seventh customer? Ooh, so first off, we see the word first. That immediately makes me think this is a geometric. I make a number line 1, 2, 3, 4, 5, 6, 7. And I'm only circling one value, which tells me this is a geometric PDF. All right. So let's go ahead and look at that on the calculator real quickly. So second vars, geometric PDF, and it asks for the probability in our X value. So P in this case is 0.2266 because that's from the previous problem, and our X is equal to 7. Now, please remember a geometric is based on the number of failures, then followed by success. So in this case, we're going to have 7 minus 1 failures. So this is going to be 1 minus 0.2266 to the 7 minus 1 times 0.2266 to the first. All right, that probability, that formula, it comes off the formula chart, and the formula chart will tell you that it's 1 minus P to the X minus 1 times P. And that's what we use right here. All right, probability of failing, and then our X value is 7. So here we go. 0.2266, X value is 7. And we end up getting 0.0484, and I'm just going to truncate, equals 0.0484. And that's our answer for this one. For the next one, using the answer in part B, what is the probability that the first customer to have the replacement is among the first 7? So in this case, Again, we're looking at the first seven. So we're going, all right, 1, 2, 3, 4, 5, 6, 7. But it's any one of those values. All right. So in this case, we're going to have to do a summation geomet PDF. And to show our work, we're going to have to start off with the lowest one and the highest one. So the lowest one, oh, and I should have done this up here. And I forgot to set my probability statement. My probability statement is a probability that X equals 7. For this one, my probability statement is the probability that 1 is less than or equal to X is less than or equal to 7. So I need to do all of those values. And once again, there's my formula. So I'm going to have to do this as a bookends because I'm going to do my lower one and my upper one. And remember, this is going to be as a summation. So this is going to be the 1 minus 0.2266 to the 1 minus 1, 1 minus 1 times 0.2266 to the first power plus dot plus 1 minus 0.2266 to the highest value, which was 7, 7 minus 1 times 0.2266 to the first. All right, now we're going to take the summation of all of that. So here we go. We're going to have to press the math button, drop down to summation, press X, oops, press 1, then this is 7. This is second VAR's geometric PDF. 0.2266 was our probability, but here's where this gets a little crazy. We don't want 7 here. We want the X to be there because it could be X is the first, X is the second, X is the third, etc. And we end up getting 0.8344. Using your answer in part B, what is the probability that 2 out of 7 customers have to replace their batteries? Well, here we have a group. All right, so here we have a group, so that we know this is going to be a binomial. So this is a binomial. And we know we have, and binomials all, remember, starting with bison, all binomials start with a 0. So 0, 1, 2, 3, 4, 5, 6, 7. And we want specifically a single value. So our probability is probability that X equals 2. All right, let's go ahead and look and see what the what it tells us that the binomial looks like. So second VAR's binomial PDF. When I look at that, it asks me the trials. Oh, so in this case, we have trials. Well, how many trials? Well, it's 2 out of 7. So our trials is 7. It asks for my probability. We got that from part B is 0.2266. P equals 0.2266. And in this case, X equals 2. They told us that. So we want the probability that X equals 2. So the binomial has the formula of N choose X, P to the X, then 1 minus P to the N minus X. So there's our formula, and we're going to have to plug in. So in this case, oops, 7 choose 2, 0.2266 to the X, this is to the second, times 1 minus 0.2266 to the 7 minus 2. So there's our work shown. Now our trials are 7. Our probability in this case is 0.2266. We got that from part D, and our X value is 2. And we end up getting 0.2983. The next one, using your answer in part B, what's the probability that at least 2 out of 7 customers have to replace their battery? All right, we have to be careful with this. First off, we have a group size, so this tells me this is a binomial. And in this case, we also have trials of 7. We know our probability is 0.2266. Our X value is interesting. All right. Our X value in this case is going to be the entire group. So let's make our number line. So 0, 1, 2, 3, 4, 5, 6, 7. We have a group of 7. And really, it says at least 2. So we're looking for that group. So we've already written our formula up here. So I'm not going to write it again. But because I have multiple values, I'm going to have to use the summation section of the calculator. And it's going to be the summation of the lowest one plus to the highest one. So in this case, n choose x, the lowest one would be 7 choose 2.2266 to the second, 1 minus 0.2266 to the 7 minus 2, plus plus, and because I'm short on room, I'm going to write it down below, which I know is not very good form, but I'm short on space. 7 choose 7.2266 to the 7th, 1 minus 0.2266 to the 7 minus 7. All right, so there's my work shown. And once again, we're going to have to go to the summation because we have multiple values. Anytime you have multiple values on this, you have to do the summation. So we're going to go math, drop down to summation, press X. We're starting at 2. We're going up to 7, second vars, binomial PDF. X is 7, P is 0.2266. Oh, and our X value is, make sure we have an X. Whenever you go to the summation, you have to use X. And we end up getting 0.4950. And I should have given my probability statement. And my probability statement should have been the probability that 2 is less than or equal to X is less than or equal to 7. All right. And once again, our answer is 0.4950. The next one, what's the probability that that a group of 9 have an average of at least 35 months? So in this case, if I'm looking at this, we have a group of 9, so we have a sample size of 9. What's the probability that they have an average life of at least 35 months? So here we're not looking for the number of people, we're looking for months. So let um, X equal the number of months. And we want the probability that X is greater than 35. Well, if I look at my normal curve had a mean of 30, and we're up at 35, and we want this, all right? Now, but because we have a group, we're going to use a different formula. We're going to use Z equals X minus mu over sigma divided by the square root of n. But please make sure that we're talking about an average. Because we're average, we have to use the X bar. And we're going to divide by the square root of n. So when we do that, we have the probability that Z is greater than 35 minus 30 over 8 divided by the square root of 9, because that's our sample size. So stat test Z test. And by the way, We can use the central limit theorem because the underlying distribution was normal. They told us it was normal way up here, so we could do it. Otherwise, we'd have to have a sample size of 30 or larger. So stat test 30, X or standard deviation of 8, X bar is 35. We have a sample size of 9. I notice we shaded to the right, so this needs to be a greater than. And we end up getting the probability that Z is greater than 1.875 equals 0.030. All right. Next one, given the battery has lasted 40 months. Oh, by the way, we're looking at a single battery. Given that it's lasted 40 months, what's the probability that it lasts more than 43 months? All right, so here's the bad news. It says given. This tells me I'm looking for an intersection over given, which means I'm going to have to do two probability statements. So I'm going to draw my graphs for this. So the given is it lasted over 40. So my graph for the 40 is going to be in my denominator. So our mean is 30, but we're up here at 40, and we're told it's this. The numerator also has the same mean of 30. And the intersection is between 40 and but lasts more than 43. All right. So I'm looking for greater than 43. So basically, this is the probability that X is greater than 43 over the probability that X is greater than 40. That's what we're looking at, right? This is what we're given. This is what we want to find out. All right. So we're looking for this area up here divided by that area. So I'm going to have to do two different z-scores. So if I do that and I'm plugging in, and remember we're plugging into z equals x minus mu over sigma, and it's a single battery, so I only have to do it once. I don't have a sample size. So this is going to be the probability that x is probability that z is greater than 43 minus 30 over 8 divided by the probability that z is greater than 40 minus 30 over my standard deviation. So I'm going to end up with two z-scores. So I'm going to do this twice. Stat test, z-test. I'm going to change it to a 43, my 1, and we already have the greater than selected. Oops. Stat test, z-test. And we end up with 1.625. So the probability that z is greater than 1.625, and that equals 0.0520. And then for the denominator, I have to do it again, stat test, z-test. But I'm changing my x to the 40 because that's what we said, probability is greater than 40. And we get the probability z is greater than 1.25. And that ends up giving us 0.1056. Oops, 0.1056. I divide those out. So 0.0520 divided by 0.1056. And I get 0.4924. All right. Appreciate you watching. Hope to see you on the next one and good luck. Thank you.